What if Earth suddenly shrunk to half its size? Not over millions of years, not slowly enough for anyone to prepare, but instantly, while you were still standing on it. 1 second, the world beneath your feet feels completely normal. The next, your body becomes lighter. The horizon feels closer. The sky seems wider, and the planet you thought you knew has quietly become something else. At first, it might not look like the end of the world. The continents are still there. The oceans are still blue. Cities still rise from the ground. The sun still shines. But a planet's size is not just a measurement. It controls gravity, air, heat, geology, oceans, and the invisible systems that make life possible. Shrink Earth too much, and you do not simply get a smaller Earth. You get a different kind of planet. The first change would happen to your own body. If Earth kept the same average density but shrank to half its diameter, surface gravity would become roughly half as strong. You would not float away, but you would feel dramatically lighter. Walking would feel springy. Jumping would become strangely powerful. A small push from your legs could send you much higher than your brain expects. That might sound fun for the first few minutes. Stairs become easier. Heavy bags feel less exhausting. Sports would look almost superhuman. But your body evolved for the gravity Earth has now. Your balance, posture, muscles, and reflexes are all tuned to one familiar pull. In a half-gravity world, even simple movements would feel slightly wrong, as if the ground no longer reacted the way it should. Falling would become slower too. A dropped object would take longer to reach the floor. Dust would stay suspended a little longer. Rain would fall more gently. Waves of sand, smoke, and water would move with a strange softness. The world would not become weightless, but everything would seem less committed to the ground, as if Earth itself had loosened its grip. And that is where the first real danger begins. Gravity does not only hold you down, it also holds the atmosphere down. The air around you exists because Earth is massive enough to keep it wrapped around the planet. Cut gravity roughly in half, and the atmosphere would expand upward and become thinner near the surface. Breathing would not stop instantly, but the air would feel different. High places would become dangerous very quickly. Cities built on mountains or plateaus could suddenly feel like extreme altitude environments. People might experience dizziness, fatigue, headaches, and shortness of breath. Aircraft cabins, oxygen systems, sealed buildings, and medical infrastructure would become far more important. Earth would still have an atmosphere, but it would no longer cling to the planet with the same strength. Weather would begin to change because weather is built on gravity. Warm air rises, cold air sinks, clouds form, rain falls. Pressure systems move because the atmosphere has weight. With weaker gravity, clouds could reach higher altitudes, storms could spread differently, and winds could behave in unfamiliar ways. The sky might still look blue, but it would belong to a planet learning new rules. The oceans would also feel the difference. Water would still cover most of the world, but lower gravity would change how waves move. Ocean swells could become taller and slower. Storm surges might behave unpredictably. Harbors, coastlines, and low-lying cities were designed for the sea level and wave behavior of this Earth, not a smaller one with weaker gravity. Tides would become especially strange. The moon would still pull on Earth's oceans, but the smaller planet would respond differently. Coastal regions could experience new tidal patterns, stronger flooding in some places, and weaker movement in others. The rhythm of beaches, wetlands, and marine ecosystems would begin to shift, because the ocean's daily breathing would no longer match the world that shaped it. The land would change more slowly, but just as deeply. Mountains are always fighting gravity. On a smaller Earth, cliffs and peaks could stand taller relative to the planet's size. Rocks disturbed by landslides could travel farther. Dust and debris could remain airborne longer. Erosion would rewrite landscapes differently. Not overnight, but over centuries and millennia. Below the surface, the story becomes more serious. A half-sized Earth would contain much less internal heat. Smaller planets cool faster because they have less volume holding heat inside compared with their surface area releasing it. That means Earth's deep interior would begin moving toward a colder future, much sooner than it should. Volcanoes would gradually weaken. Plate tectonics could slow down. The great underground engine that moves continents, builds mountains, recycles carbon, and renews the planet's surface would lose power over geological time. Earth would not become dead immediately, but it would begin aging faster, like a living world pushed closer to silence. That matters because geology is part of the reason Earth stays habitable. Moving plates help regulate carbon dioxide over enormous timescales. They shape oceans, raise continents, and return buried materials to the surface. If that cycle weakens, climate stability becomes harder to maintain. A smaller Earth would not only change life on the surface, it would weaken the machinery beneath it. The magnetic field could also be threatened. Earth's magnetic shield comes from motion inside its metallic core. That shield helps protect the atmosphere from the solar wind, a constant stream of charged particles from the sun. If the smaller planet cooled faster and its core became less active, the magnetic field could fade over time, leaving the atmosphere more exposed. This is where the story starts to sound familiar. Mars is smaller than Earth. It has weaker gravity, a thin atmosphere, and no strong global magnetic field like ours. Long ago, it may have had rivers, lakes, and a thicker atmosphere, but being small made it harder to stay warm, active, and protected. A half-sized Earth would not become Mars overnight, but it would begin walking down a similar path. Life would face pressure from every direction. Plants would grow under different air pressure and weather patterns. Animals would move differently under weaker gravity. Birds might jump into the air more easily, but thinner air could make flight harder. Insects, trees, oceans, and ecosystems would all be forced into a world where the basic background conditions had changed. Human civilization could adapt, at least for a while. Buildings would need new engineering standards, aircraft would need new designs, farming would need to adjust to altered rainfall and pressure. Medicine would have to deal with long-term effects of lower gravity and thinner air. The first generation might survive the change. But every system supporting modern life would need to be reconsidered. Space travel would be one of the few things that becomes easier. Rockets would need less energy to escape the planet. Launches could become cheaper. Reaching orbit would be less difficult. Humanity might become a spacefaring civilization, faster on a smaller Earth. But the same weaker gravity that helps rockets leave also makes it easier for the atmosphere to escape. From the surface, the world would feel more fragile. The horizon would curve more sharply because the planet is smaller. The moon might feel more imposing in the sky. Long-distance travel would cover a larger fraction of the globe. Maps would still look familiar, but the scale behind them would feel wrong, as if Earth had become a miniature version of itself. From space, the new Earth would look beautiful and unsettling. Blue oceans, white clouds, and familiar continents would wrap around a smaller sphere. It might still look alive. It might still look like home. But hidden beneath that beauty would be a planet losing heat faster, holding air more weakly, and relying on protections that may not last. The most important lesson is that Earth's size is not an accident we can ignore. It is part of why this world works. Earth is large enough to keep a thick atmosphere, active enough to recycle its surface, and strong enough to protect liquid oceans for billions of years. Change its size too much, and the balance begins to fail. So, what if Earth shrunk to half its size? You might survive the first day. You might even enjoy feeling lighter. But over time, the air would thin, the weather would shift, the oceans would behave differently, the interior would cool, and the invisible shield around the planet could weaken. Earth would still exist, but it would no longer be the world that made us possible. Perhaps that is the strange truth hidden inside this impossible question. Life does not depend on one thing alone. Not just water, not just sunlight, not just air. It depends on a planet being the right kind of world in dozens of quiet ways at once. The weight of your body, the breath in your lungs, the warmth beneath the crust, and the sky above your head are all connected to the size of Earth itself. And only when we imagine that size changing do we begin to understand how perfectly balanced our home really is.